So welcome everyone. I'm Mike Ranieri from Dell Technologies. I'm one of the co-chairs of the Redfish Forum. We also have Bill Scherer here from HPE. Bill, can you say hi?
Hello, everyone.
Thanks, Bill. And so we'll be discussing the release 2025.3 bundle of Redfish. So to go over the main highlights, we've released a new version, minor version of the Redfish specification. It's at 1.23.0 now. We've added language to the spec about using multi-part HTTP operations to import configuration files to a service. We've also added a clause to define how a client can connect to WebSockets provided by a service. So now there's a kind of common WebSocket related interactions that can occur with Redfish services. We've also released a new version of the message registry bundle, version 2025.3. Some of the highlights include new messages to the environmental registry that includes valve and leak detector related events. We've added new messages to the power message registry to indicate power types of operations that occur at a chassis level, such as, did a chassis power off or power on? So those kind of large scale types of power operations. And then we've also added new resources to the privilege registry. So you'll see this in a couple slides. There's new resources defined for certificate enrollment capabilities. There's also a new version of the schema bundle, version 2025.3. Some of the highlights include the new certificate enrollment schema to support automatic certificate enrollment for a service. Some of the minor updates to highlight. We've added new functionality to support what we're calling a local image repository. You'll see that later on. And we've added export and import configuration actions on ComputerSystem, CoolingUnit, and PowerDistribution. We've extended, we've had some major extensions to the cooling connector, cooling loop, and cooling unit models. We've added port splitting capabilities for network adapters, so you'll see those types of changes in network adapter port and port metrics. And then we've also added new multi-physical function capabilities to storage and storage controller. So going into automatic certificate enrollment, so this is where we have new resources defined to support this capability. So certificate enrollment is a resource that's used to facilitate automatic certificate enrollment using a standard enrollment protocol such as ACME and SCEP. So each certificate enrollment resource represents a single automatic enrollment configuration, and it contains parameters such as the CSR contents that you need to convey to your provider for automatically onboarding a new certificate, the different types of ACME and SCEP settings, such as where your provider exists and what types of authentication methods you may need with that provider, and the location of the target certificate to renew automatically, such as your manager's web server certificate. And so the expectation is when this is configured properly, the service will automatically use that provider to renew the reference certificate once it starts approaching expiration. And so where you'll see this is in the existing certificate service resource, we've added a new object called automatic certificate enrollment that has capabilities of the service for performing automatic certificate enrollment. And then there's your certificate enrollment collection hanging off of certificate service to show all the configured automatic certificate enrollments. So some of the other updates, we already went through a bit of them. So we've had that automatic certificate enrollment property to certificate service, the new pointer from certificate service to the certificate enrollment resources. And then there's also the enrollment CA certificates property. So there's a new certificate collection underneath certificate service to show you the allowed CAs that are can be used for automatic certificate enrollment. Moving on to local image repositories. So there is a new property added to UpdateService called LocalImageStore. And this is a collection of software images stored by the service that the client can use later. So think of this as, maybe I have an ISO. I don't want to host it remotely on a web server. I want to push it down to the service to keep it local, and the service could use that for virtual media operations later on. We didn't create a new resource definition for this, so it's using the existing software inventory resource structure. We've added a parameter to both simple update and the multi-part HTTP push updates to indicate this image I'm providing, I want you to save this in your local image store. And so that clients can set that flag, and that way you can direct the service to not treat it as a traditional firmware image or software image. It's a user provided image to store locally. And so in the end, once you go through that flow and install that image, you can, like with virtual media, if you want to try to mount that image, using the existing insert media action, for the image URI, you just make a relative reference to that local image store URI. So in this case, instead of pointing to an external web server to mount contoso linux.iso, you point to a Redfish resource at this point. Moving on to export and import configurations. So we've added new actions to ComputerSystem, CoolingUnit, and PowerDistribution to export called export configuration. Many products support this capability today through OEM means or through web UIs, but this is now a standard Redfish way to be able to request your service to export its current settings as a file of some format. And you, as a user, you can use that and take that and apply it elsewhere. But for the export setting, you're given options to control how much data is exported. Maybe you don't want to extract user account information. Maybe you don't need network setting information because you're going to apply this elsewhere and you don't want to create network collisions. But it can take things out like maybe your BIOS settings are important to you. Maybe there's a volume information and RAID configurations you need to copy elsewhere. So you can get all those out as a file. And then with a new property added, multi-part import configuration push URI, on the same resources, you can use that URI similar to how you would apply a firmware update. You could push down the file that you extracted to other devices, or maybe you have to try to clone a system because you're replacing one. Maybe it had a faulty component, but you want to preserve the existing settings and not have to reconfigure too much. And so, as an example, here's a potential call to export configuration on a computer system. So there's an export type parameter to kind of dictate the scope of what you're trying to export. Replacement is effectively, I'm trying to collect everything out because I'm replacing this system. This is the kind of the most drastic case. Here for components, I just want everything. Everything the service supports for exporting, I want to take it all. So it's not being granular about what exactly is taken out. And in this case, it's also requesting to encrypt the file. So if you have sensitive data in the configuration file, you may want to protect that to some extent. And so having an optional passphrase and specifying that sensitive data is included. And so the response back from this is contains a location to a URI of the file to download. So after you get back your successful response, you could go to the location header URI and download the configuration file. On the import side, very similar format to the multi-part push update. In this case, we're doing a post to the URI that was provided for the import configuration on system 1 using the multi-part format. There is an optional JSON body that goes in. So if you there is a JSON body that goes with the request to specify parameters in this case. Because this is an encrypted file and it had a passphrase, you need to give the service you're sending this to the passphrase to open up the file. And then the final form portion contains the actual raw configuration file. All right, and now I'll pass it off to Bill to go through new chassis additions.
Okay, thanks, Mike. So yes, we've added new chassis additions to describe sort of the physical size and properties, especially for rack mounting. So we've added rack mount capacity units, which is the number of rack units that are part of a rack. Rack mount width is a spec-based width in the whole pattern for the rack itself. And then rack mount depth millimeters is the maximum depth of the chassis in terms of how large or how deep a component can be added into the rack. And then for any chassis, we can describe its height in rack units now. So the rack units property, which can be either EIA, which are 1.75 inches, or OpenU, which is 48 millimeters, depending on whether you want to do metric or imperial units. And then height rack units is the height of a chassis-based item in U, in rack units. Moving on, we've added enhancements to coolant collector and leak detection. So we've got a new valve control action in coolant connector, which lets you control the state of a valve regardless of what the set point is. This is independent control but beyond what is handled by the set point. So the valve state, or the valve control action, has two parameters. The first is a new valve state, either open or closed. And then optionally, you can provide a reason for why you're adjusting the state of that valve. So those reasons can be normal for, well, it's just normal operation. And another parameter can be not in use. Closed because there's no connection. So this is an absent state. And then finally, you can say leak detected. We've detected a leak and we need to shut this off to make sure that something doesn't get out into the environment that isn't supposed to be there, or something that needs to stay inside the system because it's not something we want getting out into the environment. And so within leak detector, we've added some additional states to leak detector state to add and enhance the reporting of these non-normal states. So we already had OK, warning, and critical, which are the existing states for leak detection. Or for, OK is there hasn't been a leak detected. We now have unavailable, so this is a new state to indicate that the leak detector has detected a fault, and so we can't actually tell what's going on with the state. And then absent is a new state that indicates that there is no leak detector installed, but we've got the capability to detect a leak, but there is no leak detector currently installed, so we can't tell you what's going on. Next, we've added support for port splitting for network adapters. So this is where you take one or more of the ports of a network adapter and physically bifurcate it, such as through the use of an octopus cable, to subdivide the lanes into one or more subports. So we've added a series of properties under a object called port splitting. And these include maximum subports, which is what are the maximum number of subports that a network adapter supports. Maximum subports per port. So for each of those ports, how much can I split it? So if max subports per port is 4, then each of the individual ports can be split 4 ways. Supported configurations is a list of the specific supported configurations for port splitting that a network adapter supports. And then current configuration is a selection from that list of the supported configurations. So that's a network adapter. So the network adapter controls what the current and available port splitting configurations are. The port schema has been updated to show and reflect the current splitting that is being done on a port. So first of all, isSplit is a new Boolean property that indicates whether a port is a physical port, false, or a subport, one that's been split, in which case isSplit will return as true. Now we had an existing property called width that reflects the number of lanes that are dedicated to a port, but we've added first lane, which tells the first lane that is dedicated to a port or a subport. So in the case of an unsplit port, first lane will be 1, and the width will be the full width of the port, and that'll be another way to see that a port is entire. But for example, you might have first lane as 5 on an 8-lane adapter, and this could be a subport that is the second half of the adapter, or I'm sorry, of the port. So let's talk a little bit more about port splitting configurations. So a port splitting configuration consists of one or more subconfigurations, each of which details the splitting for one or more physical ports. And so across the set of subconfigurations, you have to make sure that you cover all of the physical ports. So each port, the configuration has to detail how each of the ports is split, but not all ports have to be split the same way. So in a 4-port adapter, the first 2 ports could be split by 2, the third port could be split by 4, and the last port could be left unsplit. And so in the case that I just described, you would actually have 3 subconfigurations. One that says that the first 2 are split by 2, the third one is the one that says the third port is split by 4, and one that says the fourth port is unsplit. So each subconfiguration has a series of properties. The starting and ending physical ports tell you which of the ports that the subconfiguration applies to. And like I said, across all of the subconfigurations, you have to cover all of the ports. Then the first subport ID tells you the logical port number that should be assigned to the subports. So this is from the outside looking in. When I address port 5, how do I know where that goes to? So within a subconfiguration, all of those subport IDs are going to be consecutive. But going from one configuration to the next one, there's no requirement that IDs have to be contiguous. You can skip them in particular. Next, subports per port tells you how many ways you're splitting. And then finally, we've got lanes and link speed gigabits per second arrays that tell you for each of those subports, how am I splitting it up? How am I splitting up the lanes? And how am I splitting up the bandwidth for the various subports in that subconfiguration? Next, we added additional support for port metrics to cover subports. So we've updated the transceiver object. At the root level, it has the existing RX power milliwatts, TX bias current milliamps, TX output power milliamps, and supply voltage. Now, instead of reflecting for the entire port, reflect aggregate values across all of the lanes for that port. We've then added a by lane object that lets you give a lane by lane breakdown of the values of those properties. So lane ID tells you what lane we're talking about. And then we've got RX power milliwatts, TX bias current milliamps, and TX output power milliwatts to give those values for the individual lanes on a lane by lane basis. And in conjunction with the splitting, this lets you detail the properties for the lane specific to that's a split port. Moving on, we've also added support for multiple physical functions in storage controllers. So there's a new class of storage controllers that are just starting to come out and reach the market where they use multiple physical functions, these are PCIe physical functions, to parallelize data transfer. These physical functions are organized by volume. Collections of drives are organized into volumes, and each of those volumes is linked to one or more of, to one of the physical functions. Now, in order to make this work, we've modeled physical functions as logical versions of storage controllers. And so there's a new MPF property under storage that collects properties that are specific to these new controllers. First of all, maximum supported physical functions is the maximum number of physical functions that the controller can support. Configured physical functions is the current number of physical functions the controller is configured to use. The controller can be configured to use a number that is different than its maximum, and that may happen in practice. Finally, there's a volume assignment policy, which controls how newly created volumes are assigned to those physical functions. So, and that has three options currently. Unassigned means nothing happens. The volumes are just left alone. Second, there's a supervisor policy, which says that one of those physical functions, which happens to be designated as a dedicated supervisory function, the drive or the volumes are assigned to that, and it's under the assumption that someone will then spread out the load later. Finally, weighted round robin assigns volumes to whichever next physical function is available to take the load. Other additions to storage, in the links collection, we've added unassigned volumes, which is there to collect all of the volumes that are not assigned to a physical function. And then we've modified the storage controller attached namespace and detached namespace. These were originally specific to NVMe, but we've extended their use. These methods may now be used to assign or remove a volume from a physical function. Now, when you detach namespace to remove a volume from a physical function, it no longer is assigned, and so we put it into the list of unassigned volumes under links that we mentioned a second ago. Storage controller.isLogical is a new Boolean function that indicates whether a storage controller is a logical entity, such as an NVMe controller, or a physical function. And then finally, storage controller.mpf properties contains properties that are specific to the multiple physical function controllers. In particular, we've got a Boolean property called isSupervisor that indicates whether the physical function can perform those supervisory duties that we were just discussing. So, as usual, we've collected up a series of schema and registry guide documents. So DSP 268 is our Redfish data model specification. Once upon a time, a long time ago now, this was called the Redfish Schema Supplement. And this contains all of the long description and informative description details from all of the schemas in a single document. And this is really intended as a resource for service and client-side developers. This has all of the gory details of the long descriptions in it. Next, DSP 2046 is our Redfish resource and schema guide, which provides the data model, the schema data, but in a rather than all of the gory detail, it's a more friendly format for end users. And it also includes example payloads for all of the various resources. Next, we've got our Redfish message registry guide, DSP 2065, which gives a nice human readable presentation of all of the message registry definitions, along with summary tables and details for each of the individual messages. And then finally, we've got the Redfish property guide, DSP 2053, which gives an alphabetical list of every property defined in the Redfish schema. And this is really intended for schema writers, either to locate existing definitions, properties, and to help us to avoid redefining property names that are already in use. So the Redfish publications repository, we have a public GitHub repo that contains an official read-only copy of the Redfish schemas and standard message registries at the URI there. And this serves to create a public, durable location that you can use to reference individual schemas or registry items, either in issue reports or forum postings or other online sources. And it's a great way for developers to automatically synchronize with the new Redfish releases using the standard GitHub tools and processes. And this repository is updated each time a Redfish release becomes public. The repository will contain materials published both as DSP 8010, which is the schemas, and DSP 8011, which is the message registries. So the CSDL subdirectory contains all of the schemas in the OData CSDL XML format. /JSON schema contains all of the schemas in JSON schema format. /OpenAPI contains all of the schemas in the OpenAPI YAML format. /dictionaries contains all of the dictionaries for use with Redfish device enablement, which is DSP 218, defined through the PMCI working group. And then registries contains all of our standard message registries. We also have a number of conformance testing tools. So the Redfish Forum provides open source tools for service developers to be able to validate your conformance with the protocol, the data model, and interop profiles. So we've got the Redfish protocol validator, which can be used to test your service when it's live for conformance to the HTTP portion of the Redfish protocol, including all of the response headers and status codes at that URI. We've got the service validator, which tests a service for conformance with the schemas, making sure that the returned payloads validate against the standard data models. This is a great first place for developers to run the tools because payload errors are much more likely to cause issues for end users and interoperability. And then finally, we've got the Redfish interop validator, which lets you take a Redfish interoperability profile and validate that a service conforms against it. And so with that, we can move on to the Q&A. So Shannon, do we have any questions today?
No, I do not see any in the chat at this time.
Okay, then in that case, let me just put out the plug. If you want to get involved in Redfish, we have our standards page with all of the schemas, specs, mockups, white papers, registries, and everything else that is part of it. We have our Redfish developer portal, which is an interactive way for you to explore resources. It's got all of our educational material, documentation. I think it has links to the YouTube series. We have our user forum, which is a great place for Q&A, suggestions, and feedback and discussion. And then at the DMTF level, we've got the DMTF feedback portal, which is a way to formally provide feedback or submit proposals for Redfish standards, as well as the DMTF Redfish Forum, and so if you're interested, please join the DMTF to get involved in future work. So thank you everyone for your time and attendance.